Okay, we're gonna try this. This is the node equation. Actually, this is the loop equation example. And so the first thing you want to do is go in and designate your currents. So I did. I1 is red, I2 is blue, I3 is green, and I4 is black. So first thing you do is define the current, and you're going to use KVL and Ohm's law to write the loop equations. And the next thing I want to do is go in and look at all the current sources and see if any of those current sources define one of my four loop equations. Okay, my designated loops. So here we go. I see that this 2 amp source right here touches both I1 and I2. So that is going to be a super loop equation in terms of I1 and I2. And I come over and I see that the 3IB source uniquely defines I4 and I2. And I come over and I see, here's another current source. The 6V delta current source uniquely defines the current I3. So, interesting. I have just about everything is defined except for the super loop, which will include I1, I2, and I4. All right, so let's get started. So here we go. We're going to define I1 and I2 first. So we're going to have a super loop. The equation for the super loop in I12 is going to be, notice that I2 is in the direction of the 2 amp source and I1 is in the opposite direction. So this is going to be I2 minus I1 equals 2 amps. So there is the super loop, the equation for that super loop right there. And then once I write it, I'm going to go ahead and take it out just so I know what's going on here. So I'm going to erase this right here, I think. Well, I erased my current. There we go. There we go. Okay, so I erased my current. I have to put current I1 back in there. So that was my one equation. All right. And so there I have that equation. Now I go up and I look at the 2,4 equation. I4 is in the direction of I2. So it's going to be I4 minus I2 equals, if I can figure out where my mouse is, well, never mind. It's going to be I4. This is the I24 super loop. This is going to be I4 minus I2 equals 3I beta, wherever I beta is. I don't know where I beta is. Now then, I'm going to take that source out, I hope. Let's see. I'm still trying to figure out what's going on here with this stuff. Okay, so there's that. It's gone. Okay, so it's gone now. And So far I've got one equation, two equations, and I have 1, 2, 3, 4 loops plus an I beta equation I have to write and a V delta equation I have to write. So next what I'm going to do is I'm going to come in and look at this super loop equation. So as usually I start down here at the bottom and I go all the way around that super loop right there. So how do I do that? So let's just write, again, you're writing loop equations in terms of KVL and Ohm's law. So here is the I124 super loop equation. So this is going to be 0 equals, okay, first sign I come to on that voltage source is 9I beta minus 9I beta, go on up, plus 4 ohms times I1. Keep on going around my loop. This is going to be plus 2 ohms times I4. Keep on going around. First sign I come to on that voltage source is plus 1 angle 45 degree amps. Keep on going around. I've got the J4 ohms, so this is going to be plus J4 times I4. Keep on coming down. Here is the first current I have that touches 2. So this is going to be plus 2 ohms times I2 minus I3. We're not at I3 yet. Keep on going around to the 8 ohms. So this is going to be plus 8 ohms times I2. Keep on going around, and I'm at the minus J2 ohm impedance, and that's going to be times I1. So I have the voltage source, the 4 ohm resistor, the 2 ohm resistor, the 1 angle 45 voltage source, the J4 ohm impedance, the 2 ohm resistor, the 8 ohm resistor, and the minus J2 ohm impedance. So 1, 2, 3, 4, 5, 6, 7, 8 pieces of the puzzle. I have 1, 2, 3, 4, 5, 6, 7, 8 pieces of the puzzle. And now we're ready to go on to I3. Notice here that I do have, oh, come on. God. What in the hell? Uh-oh. What's wrong? Where'd it go? Where'd it go? Where'd it go? Where'd it go? No, 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 no. God. Oh, God. You know, I hate this stuff. And unfortunately for y'all, y'all are in trouble. Okay, so there we go. So now let's see if I can get this thing to write. Here we go. The I3 equation. And so I noticed that I3, if I go up here, I notice that I3 is in the opposite direction of the 6V delta. So then I3 equals minus 6V delta. And that's the other loop equation. So I3 equals minus 6V delta. Now you could put that as V delta equals minus I3. That's okay. All right, let's go see what's going on now with I beta and V delta. Well, I come up here and I look at I beta. Not that you can really read it, but here is I beta, and it's going in this direction, and my I4 is going in that direction, opposite. So I need to say that I beta equals minus I4. Or vice versa, whichever one you want to write down. So this is my I beta equation. and I beta equals minus I4. Okay, and now I need to find V delta. What is V delta doing? Well, if I come up here, V delta is plus to minus, and only I1 is in there. And so for that to happen, this is really minus I1, is it not? Ohm's law states that the current has in the plus sign of voltage drop. So if that's the case, then V delta the V delta equation is going to be minus I1 times 4 ohms. I have the I beta, I have the V delta equations, and then I have 4 loop equations. Exactly what I need. I've got 4 equations for my loops, I1, I2, I3, I4, and I have the 2 equations for my independent sources, I beta and V delta. This is a pretty good problem, to see something like what would be on the tests. In fact, this problem was on a test a couple semesters ago. You should be able to handle something like this. So anyway, that'll do it for this video. Please let me know if there are any mistakes, which I'm just as stressed out as y'all are. So we'll see how it goes. Hopefully tonight I can get this going, and we'll get Zoom or Panopto working. I'm hoping Zoom, but we'll see what's going on.